All right, it's time to review our last 2 units of the year, which were matrices and conic sections. So with matrices, we started off with some definitions and terms, one of which was the dimensions. So dimensions means rows by columns. So in this first one, I have 3 by 4 matrix, and the next one I have a 1 by 4 matrix. We also talked about, say, I called this first one matrix A, that saying something like A sub 2, 3 doesn't mean 23, it means row 2, column 3, which would be -3. So we talked about that as well, this being row, column. Then we did operations. When we're adding, subtracting, you need to have the same dimension, so the same 2 by 3 or 2 by 2. B and D in these examples are both the same dimension, so I can do my thing. So B plus D just means I'm going to add the 2 together. I really want to be lazy right now, so I'm going to be lazy. Yeah. So 9 plus 2 is 11. -1 plus 3 is 2. 2 minus 4 is -2. -3 plus 0 is -3. 4 plus 4 is 8. 1 minus 7 is -6. Then we have D. So 2, 3, -4. 0, 4, -7. Minus, I'm going to go ahead and multiply everything by 2. 18, -2, 4, -6, 8, 2. And then I'm going to subtract. So that would be -16, 5, -8, +6, -4, -9. The other thing you could have done is distributed that negative through already. Now we're going to look at some multiplication. So remember when we're multiplying and we're trying to do row by column times row by column, that the dimensions in the middle, these need to match. And then your answer is going to be whatever the first row is by the last column. So in this first one, I have a 1 by 2. Quite the struggle bus today, y'all. And then a 2 by 1. So since the 2 and 2 match up, it is going to be fine, and my answer is going to be a 1 by 1. So in good fashion of being lazy, I am just going to move that 3, -1 down. So 3 times 5 is 15, minus 7, because -1 times 7. So my little teensy tiny baby little cute matrix is 8. Isn't it cute? I think it's cute. Alright, the next one is a 2 by 2 and a 1 by 2. Since those don't match, this is going to be undefined. With matrices, you don't want to say no solution. It's undefined. Okay? Next, we have a 2 by 2 and a 2 by 2. That's kind of boring. So these will definitely work. Once again, just going to move down. Order matters when I am doing matrices. So it does matter that I'm pulling down this first matrix and not switching them. Okay. Let's zoom in so I maybe have enough room for this. Ha ha ha. So funny. Alright, 9 times 0 is 0. -3 times 4 is -12. 9 times 1 is 9. -3 times -2 is 6. Then 0 times 0 is 0. 2 times 4 is 8. 0 times 1 is 0. 2 times -2 is -4. So my matrix is going to be -12, 15, 8, -4. This next one, we are starting with a 3 by 2, multiplying a 2 by 2. So they are going to have a defined answer, and it's going to be a 3 by 2 matrix. I don't think they wrote it quite nice enough for me to just copy and paste, so I'll stop being a little bit lazy. Just a little bit. Bring down the first one. Bring out your dead. Alright, do your grid. Alright, 5 times 3 is 15. 2 times negative 2 is negative 4. 5 times 7 is 35. 2 times 0 is 0. 0 times 3 is 0. Negative 2 times negative 4 is 8. 0, 0. 1 times 3 is 3. 6 times negative 2 is negative 12. 1 times 7 is 7, and then 0. So my resulting matrix is 11, 35, 8, 0, negative 9, and 7. Next, we're going to look at the determinant. The determinant is if I have a matrix A, B, C, D, the determinant is AD minus BC. Some of you are getting in the habit of starting to find the inverse and then doing the determinant of the inverse, but that's not technically, you get the same answer. But I want you to know that the determinant is separate from the inverse, even though it's related to it. So here it would be negative 10 times negative 6 minus 9 times 6, or 6 times 9. So 60 minus 54 would give me 6. When I want to find my inverse, the first step is to find my determinant. So my determinant here would be 20 plus 40, so 60. I then take my determinant, I do 1 over my determinant, I switch the location of A and D, and then I change the sign of B and C, so negative 8 and positive 5. Now I distribute in the 1 over the determinant. So here that would be negative 5 over 60, negative 8 over 60, 5 over 60, and negative 4 over 60. And usually I'd want you to reduce those, but we're in the end of year slightly lazy mode right now. So we're gonna go with it. All right, negative 10 times negative 6 minus 6 times 10, and I get 60 minus 60, which would be 0. So there is no inverse, or the inverse is undefined because your determinant is 0 and you can't do 1 over 0. All right. Next, now we're going to solve a system of equations using matrices. Now this one would be really easy to solve without matrices, but remember, sometimes life isn't so nice, and maybe this isn't going to turn out nice. Maybe we get fractions, but just looking at it, it seems like it'd be easy without matrices. So the first thing we need to do is change this to matrix form. So it's going to look something like this. You're going to copy and paste the coefficients in just like you see them. Negative 1, 2, 3, 1. And then we have our xy, and negative 17, negative 5. Now what I need to do is find the inverse. So for this one, my determinant is negative 1 times 1 is negative 1, minus 2 times 3 is 6, so my determinant is negative 7. So for this, I'm going to do 1 over my determinant, so 1 over negative 7 times, switch the location, for A and D and switch the sign for B and C. I'm going to multiply by this on both sides of my equation. But because order matters with matrices, you have to have the inverse in the front. It matters. I know it seems like the most trivial thing ever that I counted off points for this, but it's technically incorrect if we don't do this. Okay? What you have written is not actually going to work if you aren't putting the inverse in the front of what we had on both sides. Once we have multiplied by the inverse on the left, it's going to simplify all the way down to just x, y. Now on the right, I can distribute that negative 1/7 in right now, but it's going to be a lot shorter if I instead go ahead and do this multiplication first. So we're going to just do our grid. So negative 17 plus 10. And then you don't have your 17's times tables memorized? Me either. Okay. 51 plus 5. So negative 1/7 times negative 7 and 56. So x, y equals 1 and negative 8. So my point would be 1, negative 8 for my solution. The next unit we covered was on conic sections. That's where we talked about hyperbolas, parabolas, ellipses, and circles. So the first thing I had you do was complete the square and tell me what type of conic section you got. When I have both the x's and the y's being squared, the first step is to get the x terms together and the y terms together and move your constant to the other side. Now I'm going to take out any GCFs I have, well not GCFs, any coefficients I have in front of the squared term. So I don't have anything in front of this first one, but in front of the y I do have a 2, so I'm going to say 2y squared plus 2y. And I'm going to go ahead and set up the right. So I'm going to add 1, that's for the x squared, and 2, that's for the y term. So that's because of this 2. And this 1, just to reiterate. Okay, now we're going to complete the literal square, x squared, split in half. Kind of zooming through this part because this wasn't where a lot of the issues were. I need to add in 9, so on the right side I'm going to add 9. Then with my y squared split in half, y, 1, 1. So that's going to be 1 right there. So I have that 1 in front, and then x minus 3 squared plus 2 in front, y plus 1 squared equals 4. And now I need it to be, because these aren't the same number, okay, I need this to be equal to 1. So I'm going to divide everything by 4. And I get conic form, x minus 3 squared over 4 plus y plus 1 squared over 2 equals 1, which means this is an ellipse. Next one. This one, only one term is squared, which means automatically I can tell you that this is a parabola. And there are several different ways to do this with a parabola. I'm going to show you the way that I saw the most common. So my squared term is y, so I'm going to do y squared plus 8y. And I'm going to move everything else over to the other side. This was what I saw the most on the test for people who did it correctly. But you can do whatever. I really don't care as long as you get the right answer. Okay, y squared split in half, 4y. Y, 4. So the left side becomes y plus 4 squared. But I added 16, so I'm going to add 16 over on the right. And then that gives me 34. Now my goal is to get x by itself. So my 2 steps to get x by itself are minus 34 and divide everything by negative 2. So y plus 4 squared minus 34 equals negative 2x. And now we're going to divide each term by negative 2. And my technically correct way to write this would be x equals negative 1/2 y plus 4 squared plus 17. Once again, it's a parabola because only one of my variables is squared. Circles. We really like circles, right? Yeah, y'all did great on circles. So my center is 2, negative 4, and my radius is square root of 9, which is 3. So to graph, 2, negative 4, and then go right, left, up, down, 3. I think almost everyone got 100 on that, so we're going to move on with our life. All right, ellipses. We did okay on the center. So center would be 3, negative 2. Pretty much we remembered how to find that. We were pretty good. We need to do square root of 16 is 4. Square root of 36 is 6. So we're going to go right and left 4 units. Up and down 6 units. Alright, and draw a really beautiful ellipse. Are you ready for it? Woo. Okie dokie. So vertices. This was our first mistake for some people. Vertices on an ellipse are not about being horizontal. They're about where it's the longest. So since this is vertical, my vertices here are going to be the point 3, 4, and 3, negative 8. Okay, it doesn't say on here, but let's do covertices are the other ones. Covertices here are negative 1, negative 2, and 7, negative 2. All right, I'm going to skip foci for a second. Length of major axis, that's just how long is this vertical axis, which would be 12. Minor axis is how long is that? Count it. It's 8. There we go. So last piece of this puzzle was foci, okay? And you were given the formula that c squared equals a squared minus b squared, but some of you didn't use it. Quite sad. Okay. Then the next mistake is we want to always do the biggest minus the smallest here. So 36 minus 16. So c squared equals 20, and c equals the square root of 20. So going back, since this is vertical, what's going to change? Of my center, my y value of my center, the negative 2, is going to go plus or minus square root of 20 for my foci. Look at your center and vertices. See how the 3 stays the same? That should be the case. Hyperbolas. These went really well for the first time. I was very pleased, actually. So the thing we have to keep straight with hyperbolas is that order matters. So the fact that my y is first means that this is going to be vertical. And I noticed a lot of you wrote that to help remind you, which is great. So my center is going to be 4, 1. You want to make sure you aren't thinking 1, 4 just because the x value is second, okay? So now we're going to sketch. Underneath y is 3, I could write, which I can't today. Alright, so start at my center, which is 4, 1. And go right and left 4, because that's what's under x, up and down 3, because that's what is under y. And I'm going to draw my imaginary box. It's not really there, but we're going to use it for our evil purposes. So my vertices, it's vertical, so I need the top and bottom of that. I need those two coordinates. So that would be 4, 4, and 4, negative 2. The other ones are called covertices. I can go ahead and sketch my little curve. For foci, you want to use the formula c squared equals a squared plus b squared. So c squared equals 9 plus 16, c squared equals 25, c equals 5. So that means my foci are actually going to have nice values. And I took either answer whether or not you did that. So this is vertical, which once again means that my y value of my center, going back to the center, is going to change. So 1 plus or minus 5. So I would take that, or the 0.46 and 4, negative 4. Also correct. And last, I had you find the asymptotes. So the easiest way to do that is from the graph, although I like doing it from the equation, but, you know, we'll do it. So rise of 3, run of 4. So y equals plus or minus 3 over 4 x, and now we're using our center, minus 4 plus 1. And that doesn't matter whether it's horizontal or vertical. It's always going to be using the y equals m x minus h plus k, which is another thing we came up with. Okay, last one. My vertex. So we're on parabolas. Parabolas mean I only have one variable being squared. Here was our first spot we got messed up with parabolas. If it's with the y, that's giving you the y coordinate. And it's inside, so it's opposite. So instead of positive 1, it's negative 1. So that means that negative 2 is giving me the x value. Okay, so there was the first spot that tripped us up. Then you need to think about which way I'm drawing my parabola, up, down, right, or left. Since it's x equals, that means it's going to be either right or left. And since this one is x equals a positive 16, that means we're going to draw it opening right. And just a little sketch like that is really all we need. Next, to get my focus and directrix, I need to find out how far the focus is from the vertex, how far the directrix is from the vertex, which means I need c. So I'm going to use a equals 1 over 4c. In my equation, a is 1 over 16. So 1 over 16 equals 1 over 4c, and I can cross multiply. 4c equals 16, so c equals 4. So that means because the parabola needs to hug the focus, it loves the focus so much, I start at my vertex, and because I've already sketched the shape of my graph, I know I need to go 4 to the right to get my focus. So that would be at the point 2, negative 1. My directrix needs to be 4 units in the other direction, but don't tell me it's that point. It's a line. Okay, so what is the equation of that line? It's a vertical line, so it's going to be x equals, and what is the x value on that line? It's 6. Okay, negative 6 plus. All right, the other way you can remember whether it's x or y equals is look back at the equation you started with. It was x equals to start with, so that means way down at my directrix is going to be also x equals. There we are. I hope you have become more enlightened.